Hey, welcome back to the channel, everybody. I am Gentry. I am a computer science instructor and researcher, and this is Single Star Software, the software development equivalent of an 8-year-old Minecraft Let's Play channel, right? So we are here to teach programming and to do it through focusing on a single application. So if you're watching this video, it's because you're interested in machine learning and you don't have any experience in the Python language, right? So we're here to learn Python through focusing on the application machine learning. I strongly encourage all of you to pick a personal project that will help you maintain that daily focus on your coding skills, right? You need to take 10, 20, 30, 60 minutes every day to bang out a few lines of code, preferably in the Python language if you're here and you're trying to learn machine learning, right? And at the end, you'll have something that you can use and that you can show off, right? And it's going to help you keep your focus on learning the fundamentals of the language, right? So we're going to let machine learning and data analytics drive our understanding of the Python programming language, right? So if you're here, it means you're new to Python, but this isn't the first video in this series. You should know a little bit of Python already, specifically how to declare variables, assign values to those variables, perform some simple operations, arithmetic, comparison, or logical on those operations. On those variables. You should know branching and looping, right? So we should be able to tell our program if condition do this, else do this. Looping means repeating some statement, some block of code one or more times based on, again, a condition, right? And you should know some basic I/O, how to get a value from the user using the input function that's built into the Python programming language, and how to print some values out of your programs using print, the function built into the Python programming language. So what are we going to cover in this video? Right? We are expanding our understanding of the Python language. This is the last video that is going to focus exclusively on how to use Python, right? We are here to learn machine learning. We're going to start jumping into that in the next video, right? But we've got to do our homework first. We got to learn some basics before we can start working on some simple machine learning. So today we are going to learn function definitions. We're going to learn simple classes, which are a tool for encapsulating some variables and some functions into one easily usable package, right? Applying tools called object orientation. And we're going to look at how to add comments to our programs and some good practices in our programs. And here we are back in VS Code. This is our coding environment. This is where we're going to write and run our Python programs, right? It's an integrated environment, which means we're writing here and we're running here. It's kind of an all-in-one package. And what are we looking at today, right? So the first thing I want to talk about are functions, right? So functions, we've already seen kind of what they do. We've seen, input, and we've seen print, and we've seen range. We've seen some of the built-in functions of the Python language, right? And every time we call a function, we've had to give it some arguments, right? That's the inputs that we put in the little parentheses, right? But I want to talk more generally about what a function actually is, right? What is a function, right? So I want us to think all the way back to your algebra class, right? Maybe 9th grade or something, and they told you this format, right? F of x equals 2x plus 2, right? We have some input, right? A variable x. We have some output defined relative to the value of the variable x. So, right, if we plug in some numbers for x, what are we going to get? Well, like if we put in a 4, right? 2 times 4 is 8 plus 2 is 10. And if we plug in an 8, right, we're going to see 2 times 8 is 16 plus 2 is 18. Right? And if we plug in 30, we're going to see 2 times 30 plus 2 is 62. Right? So we're always going to have some range of input values, and we're always going to have some range of output values, and the function itself, which we've called f in this example, defines a relationship between the input values that we call the domain in math classes, right, and the output values that we call the codomain or the range in math classes, right? So a function, when we think about it like this, is a relationship, right? It defines for every input what output value does it belong with, right? And it doesn't have to be a unique relationship, right? So if we do something like f of x equals x squared, right, then for 4, right, our output would be a 16, and for negative 4, our output would be a 16 because negative 4 squared is 16, right? So that value from the domain of the function doesn't have to be unique, right? It's not the only number that pairs up with this right-hand value 16, right? But the important thing to make a function is that every input has only one output. Every value in the domain only has one co-value in the range, right? So this is a mathematical sense of a function, right? So how do we take this mathematical understanding of a function and build it up into a programmatic understanding of a function, right? So let's start with a new keyword in the Python language, def. Def is short for definition. I feel like I've misspelled definition, but it doesn't matter because what we actually need is def, right? The word in the Python language is def, right? So anytime we type def, we've started out the definition of a function. Anytime we start out the definition of a function, we have to give it a name. It's a good practice, just like when you're naming variables, give a function a name that's going to help explain for your user what that function is going to do, right? So I don't know what this one is doing. It's just a simple demonstration. So I'm just going to call this myfunc, right? And now we're going to open up a set of parentheses. And in here, we're going to define our inputs, what goes into the function, right? So let's just recreate this same function right here. F of x equals x squared. Our input is just going to be a variable that we're going to call x. Now in Python, I don't have to say what the data type of x is, right? I just have to tell my function, you're going to get a variable named x, and it's going to have some value in it, right? To be helpful to your user, you can tell them what the data type of x is going to be. Here we're looking at right, a domain of values that were all integers, so let's just run with that, right? And now to start defining the body of my definition, right, my function definition here, I need to drop down into a block of code, and that means I'm going to indent, right? Remember that the Python language always uses indentation to show that a block of code belongs to some particular segment, a function definition, an if statement, an else statement, a while loop, a for loop, right? They all use indentation to indicate that some code belongs to some segment of the program. And I'm going to use a special keyword here, pass, that just means do nothing, right? And I'm going to put that there for now just to make the error go away, right? I've got a developer's sense of being very annoyed by those red squiggles, so I don't want them to show up while I'm talking to y'all, right? Because we're not done with line 9 yet, right? Just like we can give a type hint for the inputs of this function, we can give a type hint for the outputs of this function, right? And I do that. I use these little arrows a lot in my notes to myself, right, to relate inputs and outputs, right? And so Python's kind of run with that too. Python lets me use this little arrow to say this function is going to output an integer. This is optional, right? If I delete that, we see that the compiler doesn't care, sorry, the interpreter doesn't care, right? It's not giving me an error or a warning, right? But this is making my code slightly more human readable, right? It's not sufficient to write code that's just machine readable, right? We also need to help human beings understand what we've written here, right? Because no coding project is ever written by one person. We always work together. All right, so I have a variable x, so let's say like y is going to be my return value. I need to store a value into y that defines this relationship between x and y. So I'm just going to say y equals x squared, right? Remember, star star is our exponentiation operator in the Python language, right? And now I need to actually output this y from my function, right? We've created a variable. This variable belongs to this function, right? So it's not visible anywhere else in my program, right? I need some way of outputting it. We do that with a return statement, right? So return is going to return some value from my program. It can be a literal or a variable. So in this case, I want it to be y, the variable y, right? So the data type of this variable needs to match the data type that we say we're returning from the function. As long as x is an integer, x squared is going to be an integer, so it's safe to say that y is also going to be an integer in this case. So I think we've done a good job here. I think we have a good function, right? We're not limited to defining functions as relationships between numerical values, right? We can also define, let's do like a Boolean one. String is too long will be its name. Its input is going to be some string, so like a word. The type of that will be string. It's going to return a Boolean value, right? So let's tell our user, like, hey, you've typed a word that's the right length, or hey, you've typed a word that's too long, right? This sounds like I need a program that's going to respond to the state of a variable in my program, and that's telling me I need a branch in this function definition, right? So if the length of a word is too long, right? So I need some way of getting the length of a word, right? A word being the variable name, a word. So I can use the len function of the Python language to get that, right? So let me try to spell a word correctly. So if len of a word is greater than, I don't know, let's say 16 characters is too long, we will return true to say it's too long. Else, right? So this branch defines what happens if the condition of this if is false. What do we do if the word is not too long? Let's just return false, right? So here's an example of a function returning a Boolean value, right? And we can write a function to return a string value if we wanted to, right? So like if we wanted to double up a word, I could name my function double up a word. Let's pass in a word. I'll just keep using this parameter name, right? So these input values we call parameters, right? The parameters are going to be matched up with the arguments of a function when we call it, right? So we're going to look at that a little bit later on, right? So a word is going to be a string. We're going to return a string this time. And now, right, how do we take a word and double it, right? So if they input, right, let's just think about this, right? If they input cat, we want to output cat, right? And if they input, I don't know, segue, we want to output segue, right? So we're going to use our string concatenation for this, right? It's the same operator as arithmetic addition, but instead of acting on an integer, it's acting on a string. So we're just going to add these together, a word plus a word. Boom, that's all we need, right? So now we have a function returning a string. So 3 examples of function definitions, 3 different return types, right? But kind of the same steps. And what we're seeing here is that we want functions to be fairly small, not like 2 to 4 lines small. These are unusually small for functions. I'm not trying to say 4 is the upper limit of the number of lines you can use to define a function, right? But you want to give a function a purpose, right? You want it to define one relationship between its inputs, which are the parameters, and its outputs, which are the return statement. So here's how we group instructions together, right? Notice here, every function has now become like a bunch of instructions. So if we go down here and I start typing some actual code, right? I want to double a word and I'm going to double, I don't know, turtle, right? If I run this, what we should see, right? So if I want to see the output of the double a word function, right? Notice here that it's returning a string, but we're not using that string for output yet, right? So I'm going to pass the return value of that function to our print function, right? So the inner function call is going to be resolved first. The return of this function is going to be passed as an argument to the print function. And when we run this now, we see the input turtle has been related to the output turtle, right? We can see that down here in my terminal. Right? So these are all groups of instructions, right? But we learned in our last video, instructions aren't all of Python, right? Every program is actually a collection of data and instructions that act on that data, right? Variables and operations is how we learned it last time, right? So if we can group together instructions into a named package that we call a function, right? So here I've put 2 statements into one package and named it myfunc. Here I've put 4 statements into a package and named it string is too long, right? Can I also then take variables and put them into a package, right? And maybe functions too, right? Can I make packages that are even bigger and more powerful than functions? And yes, I absolutely can, right? So we're going to do that with class definitions in Python, right? So a class is a collection of variables and functions, right? Attributes and methods, member values and member functions, right? If you've been studying in other sources, you've probably heard a few different ways to refer to the data and instructions that belong to an object in a program, right? And, right, Python has standards, but I don't think we have to be rigidly bound by them. If you are more comfortable with any term more than another one, run with that, right? Correct that behavior if it's confusing your coworkers or your colleagues, right? But until you get to that source of conflict, right, call them what you want. Call them what makes sense to you, right? So a class is a new data type, right? So just like int and stir and bool are data types in our programs, class is going to define a data type, right? So we're teaching a class. That word overlaps with our Python keyword here, right? But we're doing some teaching in this video, right? So let's think about what it would take to model a student in a video, right? And I might think like a student is going to have like a GPA, right? And I might think that a student is going to have like a schedule, right? And a student is going to have like a home address. Yeah, so like these are the data values, the data members that I would want to associate with a representation of a student in my program, right? And so I'm going to create these variables. I'm going to create them inside of a special function, right, called init. Sorry, this is a function definition, right? I'm going to say that this function takes no inputs, right? And notice here, this name starts with 2 underscores, right? This is something the Python language does to mark reserved words. We're going to see another one of these later in this video, right? So init is a special word, right? Init is going to be a special function that runs whenever we create a variable with this data type, right? So if I come down here and I create a new student, right? And I build this and I run this, we're still going to see turtle, and I'm going to leave that there because I don't know, turtle is just delightful to me somehow. Right? And I'm forgetting something here, right? What I'm forgetting here is another special keyword in the Python language, self. Self is a self-reference in Python, and we can get more into what a reference is later on, right? But a reference for now, let's just say it's like a way that the interpreter can access, right, a place in memory that is associated with a named variable, right? So this constructor, right? And a constructor is a special type of function that we discuss in computer science, right? That runs when we create an object with the data type of a class. We call this instantiating the class, right? This function is going to run every time, and it needs to kind of know where it lives in memory, right? So let's run this. Okay, so now S is a variable in my program. How do I know that this constructor actually ran? Right? Well, let's throw a print statement in there. Right? Making a student, it'll say. Right? So now every time I create a new variable with the type student, we're going to see that. Right? Making a student. Right? Whoop! I don't know how I lost a parenthesis there. Alrighty, t equals student, right? Now I've got 2 variables, they're both students, right? And we can see that our constructor ran twice, right? So now how do I get those special variables into my class, right? We're going to take advantage of this constructor, right, to create variables, right? We're going to learn a new operator now. The dot operator is how we get to member values in a student, right? So remember that in Python, assigning a value to a variable that the interpreter hasn't seen before creates that variable in memory. And we can do that even inside of a class definition, right? So every student is going to start off with a 4.0 GPA, right? Every student will start off with a list of classes, a list of lectures they go to every day, right? A list, we can make an empty list just with empty square brackets like this. Every student will have an address that we're going to initialize with an empty string like this, right? And now, right, we're still not seeing any output, but if I want to print S's GPA, S's GPA, right? I can pass, remember, I can pass as many arguments as I want to the print function. So s dot, that dot operator is how we're going to access the member values of an object, right? So when we run this, we should see turtle turtle and then 4.0. Hey, look at that. S's GPA is 4.0, right? So every student is starting off with an empty schedule and an empty address. Man, and wouldn't it be cool if we could pass in these values as parameters, right? That would actually make our constructor a whole lot more useful. And so, yeah, I can add parameters to my init function, right? I can add, right, a schedule would be like their list of lectures to attend. Their address would be the string of the address where they live, right? And now I can set the data members of the class, which are referenced using self dot the name of a data member, right? And I can use the assignment operator to put a value in there, right? So even though the parameter and the data member have the same name, self dot is going to disambiguate those variable names for us, right? So disambiguate means clear up the ambiguity. It means helping the compiler figure out which variable we're talking about when several variables have the same name, because that is legal in Python, right? The parameter GPA and the attribute GPA don't conflict with each other. And I can tell the compiler, I can tell the interpreter which one I'm talking about, right? Using that self dot. So let's do that. Self.schedule equals schedule, right? Self.address equals address, right? And now if I jump down here, if I try to build and run this, I'm going to get an error. Right? VS Code is very helpful about this, and it's another nice thing about the Python language. Any of y'all that have had experience in older languages, something like C or C++, right? Finding the exact line where an error occurred can be tricky, right? Sometimes it's easy, right? But it can be tricky. Python is much nicer about telling us exactly where things went wrong. And what it's telling us here is that init, right, the special name reserved for our constructor, requires this number of arguments, right? The number of arguments, which are the inputs of a function call, have to match the number of parameters, which are the inputs of a function definition, right? So this is saying, hey, you told me you were going to give me a GPA and a schedule and an address as inputs to this function. Why didn't you do that, right? So we have to fulfill our promise to Python. I'm going to stop the run of that program just to make the big ugly red box go away. So we have to input a GPA. Let's say S currently has a 3.8. A schedule, a list of lectures for the student to attend, right? We can input that as like a list literal here. So let's say they're in like CS 101. They're in English 203, and they're in, Math 415. Their address, we're going to enter that as a single string. So let's say they're at 315 Happy Lane. Right? And if now I build and I run this, we're still going to see our error, but we see it later in the program, right? Sometimes that's the best progress you can ask for, getting the error to show up somewhere else, right? So now, right, one instantiation of the student class to make the object named S is working, and this one breaks down because we've got the wrong number of arguments in it, right? So let's say the student T has like a 3.6. They are in CS 102, they're English 213, Math 318, and they're living next door. They're in 317 Happy Lane, right? So now I'm going to use NVS Code. The little circle back arrow here restarts a run of your program if you've hung up on an error like this. If I restart, boom diada, we got all the way down to the print statement, right? These function calls, right? These are calls to the init function. Don't actually have any output, right? There's no print statements in here, so we don't see anything from them. So the first output we see is here, right? So if we wanted to output some more information about our student, let's say we want to know how many classes our student is in, we can write a new function for that. I'm going to call it get num of lectures. Sorry, I'm going to keep using lectures just to disambiguate when I'm talking about class definitions and when I'm talking about lectures that students attend at a school. Right, so get num of classes. It still needs self as an input, right? That's not true. For now, every member function of a class is going to have self as a parameter. It's possible to define class functions without self as a parameter, right? We're not going to worry about that right now. Just put that in your back pocket for another day, right? So now, this is a one-liner. Many functions in Python can be defined in a single line of code, right? We want to get the number of classes that a student is attending. So we're going to use that len function again, right? Len behaves one way when its input is a string, and it's going, right, it returns the number of characters in that string. When we pass it a list, it's going to return to us the number of elements in that list. So let's see how many classes a student is taking, right? We're going to return the length of their schedule, right? And if I want to return or to refer to the member attribute, right? This little data member here of this class, I have to use self dot to get to that, right? If I just type schedule here, right, the interpreter is going to think I'm referring to some local variable. There's no function, or there's no variable in this function named schedule, so I'm getting a yellow squiggle here, right? VS Code is already mad at me. So I want to tell it, hey, I don't mean a local variable, I mean the class variable. All right, so let's see what that looks like. We will say S is in. Then we're going to call a function that belongs to the object S, right? Object is the name, S is the name of a variable in memory. When that variable has a data type that is a class, we call it an object, right? So to get the number of lectures that S is in, we're going to use the get num of lecture function. Since it's a function call, it needs to have a set of parentheses after it. And now, right, I can keep passing arguments, right, just to get myself some clean, nicely formatted output. So S is in function call lectures. So when we run this code, what we expect to see is still turtle, and S's GPA is 3.8, and now S is in 3 lectures, since that is the length of the list we have passed to the constructor. Run and debug. Here it is. S is in 3 lectures. We're looking good. All right. So, our code is working, right? Our code is machine readable. I know that because the interpreter can read my code and produce some good output, right? The problem is machines aren't the only one reading this code. Actual human beings have to read this code at some point too, right? So, how can I tell my users, right? And when I say users, I mean the users of this code, not the users of the compiled program, right? How can I tell them, right, what functions are supposed to do, right? So we've seen comments. Comments are a way of communicating with readers of our code. That reader could be some other human being that you're working with, and it could be you in 6 months when you come back to this file and have completely forgotten what you were doing, right? So you can say, hey, my func, right, parameters right? One integer, right? What does it return? The square of its input, right? This is a pretty solid way of writing function comments. If you know that you're going to be writing comments over several lines, Python has given us another tool for that. 3 quotation marks, 3 double quotes in a row will make a multi-line comment. So anything that I type in here will be a comment. The compiler will ignore it. Right? So functions are relationships, right? It's important to explain to our users in terms of inputs and outputs what our function is going to be doing, right? So I'm going to make a deal with the users of my code, right? Essentially, we're writing here a contract with our users. I'm going to say, hey, right, you're going to give me a string. I'm going to give back to you, right, like, oh, true, if that string is greater than 16 characters. Otherwise, false. Right? So now anyone who stumbles across this code file out in the wild, right, is going to know how to use this function, right? And they're going to know that without having to read my code, right? Never, ever, ever rely on another coder's ability to read your code, right? We all know that everyone we've ever worked with has no idea what they're talking about, right? And I'm sure they think the same of us, right? So give them good English language or the language of your choice, right? Give them good human-readable comments to walk them through what they're doing, right? And if you're doing something, right, particularly difficult inside of a function, right, you can give them little comments in here too, right? Use string concatenation, I might say, right? Just in case people don't recognize that the addition operator behaves differently in some situations, right? And our classes, right, we can do the same thing, right? So like model 1 student, right, for the constructor, right, we can put in some function comments here, right? So parameters, we don't need to list self as a parameter. That one's sort of implied, right? That's the object we're trying to create, right? But like a float GPA, right? A list schedule and a string address, right? We can also convey this information with type hints, right? We can say, hey, you're passing in a float, you're passing in a list, right? And you're passing in a string, right? Right, but the more readable, the better. It doesn't hurt to do both of these. Something else I'm noticing as I'm looking at this code is that, like, I've got definitions all over the place, and I've got executable code all over the place. It's really hard to open up this file and read through it line by line and actually figure out what's going on, right? Like, this block of code doesn't execute until this function is called from somewhere. This block of code here on line 35 always executes because it's not inside of a function definition, right? So it would really be nice if I could make a distinction in the file between which code was going to execute when you run and debug it and which code is part of a definition, right? And it's going to wait for a function to be called or a class to be instantiated, right? And so we can do that. We're going to do that with the if keyword that we learned last time, right? We're essentially defining a branch that's going to say if the name of this file, right? And the name of the file isn't this one that it's been saved as, right? It's the name of the process that's being run when you execute this file, right? So we're using another one of these double underscore reserved words if the name is equal to double underscore main. We're going to put something in this branch, right? And I'm throwing in a pass down here just to keep the red squiggles away, right? But just take a moment to remember this line of code. This is important in Python. It's important enough that many IDEs will fill this in for you, right? Code blocks, if I had typed a little slower, might have recognized what I was doing and finished this line of code for me, right? Because this is how in Python we're going to separate executable code from class and function definitions, right? Everything that's executable, I'm going to put into what is standing in for a main function, right? Those of you that have seen some C, C++, Java, any other programming language will be familiar with the practice of including a main function in a program. That's essentially telling the compiler or interpreter, hey, start running the program here, right? And it's gonna serve the same purpose in this Python program, right? We're going to take all of our executable code and put it in our main block, right? Some Python programmers like to kind of belabor this point and define a function whose actual name is main, and all of this stuff would go in here, right? And then from main, in this branch we just call the main function. I personally do not do this, right? I think that it is expecting Python to look more like other languages than it wants to, right? In effect, right, these two programs that we just saw, right, with and without a function named main, are programmatically equivalent, right? They're going to run and have the exact same output, right? And this, I think, is the more Pythonic solution. I think this more embraces Python's place as a scripting language, right? Yeah, and right, any of y'all that like have some experience in Python, A, I don't know why you're watching this video. B, right, you know that Python actually is a partially compiled language. It compiles to bytecode before it runs, right? But it still has the heart and soul of a scripted language, right? And I think it is more appropriate to treat it like that and structure your code like this, right? So I don't really need function comments for this. I'm not going to put in my 3 quote comments here, right? Don't need this, right? But I can put in my single line comments in here, right? To kind of explain for the user, right, what's going on in here. Really, you want to include single line comments with more complex lines of code. These aren't particularly complex. These are all variable declarations and print statements, right? But we could include, I don't know, S and T are students. Just really assuming the worst of whoever's reading our code right now. All right, like I said, this is the last Python-focused video, right? And when I say that, I mean the last video focused exclusively on Python. If you join us for the next video that will be dropping in about 2 weeks, we are going to start jumping into machine learning and letting our exploration of machine learning drive some more understanding of the Python programming language. Thank you so much for joining us. I have been Gentry. If you want to stay with the channel, please subscribe. If you want to show that you enjoyed this video, please like the video. And if you have any feedback, I'm absolutely open to it. Please leave it in the comment below. I'll see you next time. Thanks so much for watching.